back to another session of Autumn of STEM. My name is Callie. This is World Space Week, so our activity today is going to focus on space. Autumn is a great time to look up at the night sky. With shorter daylight hours and mild temperatures, you can see a lot this time of year. What do you think you'll see? Planets? Stars? What about man-made things like satellites or the International Space Station? Have you ever wondered why astronauts on the space station just seem to float around? Our activity today is going to help us find out. To begin, ask an adult to make a hole in the side of your cup towards the bottom using your pencil. For the first part of our experiment, we're going to cover the hole with our finger and fill the cup with water. What do you think will happen if I let go of the hole that we've made in the cup? Shall we try? As you can see, the water is pouring freely out of our cup and into our jug. This is because of gravity.
Gravity is a force exerted by all objects with mass that causes them to be attracted to each other. The huge gravitational force exerted by Earth pulls everything on Earth, including us and cups of water, towards its center. In the first part of our experiment, gravity wants to pull the cup and the water toward the Earth. Our hand is strong enough to resist gravity's pull on the cup, but gravity is able to pull the water through the hole.
For the second part of our experiment, we'll start the same way, by covering the hole we've made in the cup and filling the cup with water. What would happen if I let go of the cup? Let's find out. 3, 2, 1.
When we drop both the cup and the water, gravity pulls on the cup and the water at the same time. In part 2 of our experiment, the cup and water were in a state of free fall, and even though there was a hole in the cup, gravity was pulling them straight down at exactly the same rate, and therefore there was no sideways motion of the water, and it all stayed in the cup. So how does this cup drop experiment relate to astronauts floating about in orbit on the International Space Station? When we think of astronauts in space, we picture them floating around as if the Earth is exerting no gravitational force, but this is not the case. Gravity on the International Space Station is around 90% as strong as it is at Earth's surface. So what is going on? If you drop an apple on Earth, it falls towards the ground. If an astronaut on the space station drops an apple, it falls too. It just doesn't look like it's falling. That's because they're all falling together, the apple, the astronaut, and the station. The weightlessness astronauts exhibit on the space station is just free fall. Because they're all falling at the same rate, objects inside of the station appear to float in a state we call zero gravity, or more accurately, microgravity.
Thank you for joining us for this special World Space Week Autumn of STEM. For your best chance to see the International Space Station in the night sky, use NASA's Spot the Station website. We'll put the details in our comments below. See you soon!